Hello and welcome. My name is Amber Schroeder. I'm the CEO and founder at Paraben Corporation, and I'm going to take you through today's webinar on digital data triage from computers and smartphones. So you really get a holistic perspective on what you can get in the least amount of time associated with the data. So the big thing, why does triage even matter to us? So the biggest problem we have is just data has been growing exponentially for a really long time, and being able to quickly assess and look at where we want to go in our examination has become harder and harder. So we want to try to make it so we have a simple steps and simple process that we can follow that is going to allow us to optimize that data that we see. As you see from my graphic I have for you here, 2.5 quintillion bytes of data have been generated over the last couple years alone. That's a massive amount, and it's nothing that you could ever deal with. And now we always talk, when we're working on our investigations, we talk in the realm of terabytes. That's going to grow up to petabytes, and we're going to keep going and going and going. So how does this affect what we're looking at? Really, at the end of the day, 20% of all of that data we have is where we're going to get the good stuff. That's where we're going to find the investigative artifacts that are going to make a huge impact to what we're looking for. So how do we get to that information? We're going to go through kind of a mnemonic that's going to help us to remember it. And there's a couple things to keep in mind with that. And the first one is about data transfer speeds. It's why we have to look at triage. When you're going through terabytes of data, you really can only transfer it at a certain speed or process, whether it's coming from a smartphone or coming from a computer. Trying to do multiple terabytes of data in a short period, and a triage time period for me is anything under 30 minutes. So that's what we're looking at when we look at all of these pieces of data throughout the webinar. So we have a transfer problem that we have to always deal with. The second is we have a data storage container problem. And I say that because our storage associated with all of the different pieces of data that are generating has been spread out over multiple pieces. We're dealing now with solid state drives, which are great because they're much faster. But the other side of it is that we can have issues with them actually imaging properly, or they might burn out quicker. We have cloud storage capabilities, so we can go from expecting our suspect to have a terabyte of data to having 10 terabytes of data, and it's all cloud-based, which is almost impossible to triage in that 30-minute time frame I mentioned. The other side of cloud that we'll have to look at here is that you really have to have consent to be able to go anywhere with the data that's associated with the cloud. And then we have the changes that are happening with smartphones, where we're getting more and more embedded information. We're having SIM cards embedded within the device. We just have always a flux happening in that smartphone market, and it really affects what we're able to get back in our evidence. So what's our final goal of triage? I always have a kind of a fun graphic for you, and in this case I have a fun treasure map, because our goal is to get to that treasure of our evidence as quickly as humanly possible. And in order to do that, that's when we're going to follow our triage approach, which is fast. Pretty easy to remember, right? We're going to find, we're going to analyze, we're going to simplify, and then we're going to look at a timeline. Because when we start looking at triage, we're trying to look at it in that quick scope. And it's going to make our decisions for what path we follow after that. Are we going to continue to image the device for a traditional image, whether it's a bitstream image, or we're going to go to a smartphone and we're going to physically image that smartphone? But either way, this is kind of what sets us down our path. So our first area we're going to focus on is to find. So whenever I go into a situation where I'm going to do an investigation, what I recommend to people is that they really go and start at the router. So whether you're in a corporate environment or you're in a home environment, the router kind of gives you that map. That's that treasure map that's going to take you to all the different pieces of evidence that you're going to be looking for. And you might be thinking to yourself, okay, that would make sense. I can see everything that's associated with my network. I can see everything that's there. But the other side of it is I always like to look at the side, and you see this redacted router on there. That's because most people do not change off of the default settings associated with their router, and it is conveniently located for you right on the side of the router, because as it comes from their internet provider, They distribute the routers and they provide all that information on it. So always go there and look. It's going to give you that map that you're looking for that says, okay, do I have 5 computers connected to this network or do I have 2? Do I have a bunch of IoT devices connected to this network? Do I have just smartphones connected? Are there extra smartphones besides the ones I've seized? This is going to give you that list, and it gives you the best starting point. So let's look at those computers. Since those are our larger storage capacity, in most cases, this is where we're going to start our examinations at. So there's a couple different options out there. There's a lot of different free imaging tools for you. A lot of people use FTK Imager. It's a great imaging tool. You can do logical images, you can do physical images, you can image RAM. So you've got a lot of capabilities there. And the nice thing, of course, is it's free. If you want to kind of bump up your nerd level, you can go over to Kali and you can use it. You can use Autopsy, also another free tool. Each one of these choices, it's really based on what your individual skill level is and what you want to work with it. Since all of our webinars, we like to invite both traditional DFIR professionals that have been doing this a long time, so you're a seasoned professional, and we like to bring in some of the new investigators and private investigators that are trying to learn more about digital forensics. We'd like to add a scope of it. So this is more for those seasoned professionals in the field, where we have an option where you can do some of the easier things for people who are just getting started, which is what DP2C is. This is a tool that's produced at Parabon Corporation, and we designed it with the idea in mind that you might want to triage and then move to full forensic imaging. So you've got a couple options off of the beginning. It comes on a bootable USB thumb drive. We boot up to a Windows PE system, and it allows you to do a quick scan of the system. You can do a custom scan if you know you're looking for something specific. So I know my suspect, their primary form of communication they were working with is email, so I'm looking for email. That's when I would use a custom scan, or I can create a traditional forensic image with it. The process is super easy to use. So if I want to do a quick scan, it's telling me how much of these little triage data categories exist. Because sometimes my map to finding those forensic pieces of evidence is not super clear, and this is a great way for you to kind of get a clearer map. Are they using instant messaging? Are they using email? Do they have the My Documents folder? Whatever you want to look at that you think are going to be primary areas, you can do so with a quick scan. This is when you can start your acquisition almost immediately. It takes that data, which are individual logical files, it puts them inside what we call a forensic container, maintains the date and time stamps, which is super important in forensics because it's all about making sure you know the context of your suspect working with the data, not you interacting with the data. And it kind of puts it in that nice, safe, I kind of think of it like a Tupperware container just for data. And then it sets it so you can get that done in that 20 to 30 minute time frame that we mentioned earlier that is so important for doing triage. If I do the custom scan, this is when I can kind of work with those categories. You'll see this consistent throughout all of the Parabon technology, is we like to look at things in context of categories for specific headers. So I want to look for all the databases, a great way for you to seek out SQLite data. I want to look for documents, spreadsheets, email, etc., graphics. All of those things can be pulled out by their header. And this is what that custom scan option allows you to do. I want to triage just that information off the drive. And especially if you know that's the context that you're looking in and that's it, then this is something you can usually accomplish within 20 to 30 minutes. You might not get to the end of the drive as far as the total space, but you're going to get through a good percentage of it. Again, put it inside that forensic container I mentioned. Keep the date timestamps solid as they were with your suspect, not with your interaction, and you're good to go. Other triage options that you have or things to consider is make sure, of course, that you can capture select data because it's not realistic for you to be able to image the entire drive in that short time frame. Make sure you're keeping those date timestamps. I always look at that limited acquisition time. Again, I'm always going to mention the 20 to 30 minutes. That's our goal for triage. And I like it to be a little more easily accessible. There are some amazing hardware options out there as well for you. And again, it's how much you want to invest in working in triage. I have up on the screen for you a CRU Ditto device. This is an amazing choice. It allows me to do remote imaging. I can do tons of different options with it. If I want to just pull the drive out of the system, which is fine for a tower or a desktop system, not so easy with a laptop depending on the laptop, I can use a variety of hardware devices to get a faster read because I'm not going through a throughput of a cable, etc. I'm working directly drive to drive. So I'm going to improve my speeds that way. These are just some of the options associated with triage on a computer. So now let's look at triaging with smartphones. So with a smartphone, we have multiple storage tiers involved with the device. We have a SIM card, we can have external storage capabilities. You always have a limitation associated with the port. You can't really force a smartphone to communicate any faster than what the port is designed to. I always also make sure I have consent when I'm working with it. So if I find cloud data, I can triage out that cloud data in that 20 minutes. And then I have the option to bump it to a process in a full lab. One of the most common questions I get asked is how long does it actually take to process a smartphone? In general, an average smartphone with not a ton of data on it is going to take at least 90 minutes or longer to process, which is well over our triage time frame. It's why you've got to start picking and choosing in your acquisition process what you want to look at. So within E3, I use the triage option, which allows me to pick and choose specific areas. So everyone always kind of wonders what happens if I pick the wrong areas? Did I miss out on some primary information? These are my quick capture lists. So I typically go for SMS data, both active and recovered, MMS, active and recovered. I always get the installed application information because, again, probably 80% of someone's time is spent inside an app on a phone. So I want to make sure I have that information, always a browser, of course. And I like to get their calendar because that's telling me whether or not this is a primary device for them. It's typically a very quick acquisition. But if they are all about where they have been, that's part of my investigation. Calendar is a great place to start looking. And then the last area there you see is I have authentication data. For authentication data, the reason I put that in my triage, that's what gives me my cloud keys, which was one of my data storage areas that I was most interested in. With the multi-device acquisition function within E3, I can then work with a device. I can then start a cloud acquisition. I have choices. And I have a tool that's threaded, so it's allowing me to capture the most amount of data in a limited time frame. One caveat. There's always a caveat, isn't there? So when I'm working with Apple devices, part of my triage process is I like to make an encrypted backup using iTunes. Now, I try to keep iTunes in a virtual machine that I have on my forensic workstation, so I always have its capabilities, but without having it contaminate my primary forensic processes. iTunes is a busy little app, and so it does have some issues when you start using it with your forensic tools. So I like to keep it separate. I make my encrypted backup with it because that's going to allow me to collect all of my keychain data, and that's also what allows me to get the authentication data that I mentioned prior that allows those cloud keys on an Apple device. So it is a critical process. I think it's something that you should just get in the habit of, because when you get the information associated with keychain data, you can get all the web form information, different passwords they've used. You kind of get a nice map of how they're using their device. And it's something that you can only get with that encrypted backup. So I think it's a critical part of the process. We will have a YouTube video up as well that walks you through processing an encrypted backup of an iOS device that should be posted in the next couple weeks that will show you kind of that value of that data. So now we're to our second section, which is to analyze. So after we've actually found the data, we've done our initial acquisition, it's time to look at some of those details that we have so we can get to our next step of the process. So when we look at overall digital uses in the world, we kind of have to find what's popular, and those are the areas that we like to focus on. So this is just a chart to really show you that with Windows 10, that's going to be most of your Windows examinations. You're not going to look at a lot of the other operating systems. There's a huge advantage to you with this because Windows 10 is full of forensic sprinkles. That's what I call all the wonderful little artifacts that are all throughout Windows 10 that really give you some key pieces of information that you would miss if you didn't have them left in the file system. So our goal is to mount and review the data prior to processing out the full file system. So when you triage a Windows device, you can typically mount it up and not go through and say, hey, I'm going to go for every deleted file. I'm going to process everything. That's the long engine processes. It's kind of the difference between cooking a full meal and then microwaving one. We're at this point in triage, we're looking to microwave it. So we pop it in and we want to see what we can get in a few minutes of time. Up on the screen here, I have for you an example of computer triage of, I think it's a 64 gig drive. So it's not huge, it was a test drive, but I was able to triage all the file system. It's a full version of Windows 10 on there. I triaged the full file system of this drive in less than 5 minutes. But look at the information I was able to find. I was able to determine how many email databases, were they using chat, what their internet browser was that they were using. I can look at very quickly their My Documents folder, the most common place someone's going to save out their data. I can look for search commands. Were they connected over into cloud storage capabilities? This is a great treasure map to what their information is doing. And then my second tier, which only took another minute longer to check through, is I can process through the Windows registry and then I find the rest of the map. So what type of devices are they connecting in? Were they the last user that was logged in? All of that information is going to come through those Windows registry details. So here's some examples of after I've triaged, and again, we're in that analyze stage, what I'm going to look at. So I knew they had an email archive. I know it's now Outlook, and I can immediately go through and then choose to process through that portion of the file system instead of, again, that full file system to be able to triage, do I have enough in that quick time frame? I can then look at their internet data, go through some of their internet history, make sure there's nothing in there that I was looking for, or is that pointing me again in that new direction for my investigation? Any keyword searches they might have done associated with their internet history, those are always the giveaway on what someone is planning. And different website logins that they have. And you look at what the huge amount of information you can get from that. Some of these were 49,000 items. This is 101 items associated with just the different logins they have for the websites. And then finally, those connections to external storage. And when I'm talking to external storage in this case, I'm talking about connection to the cloud. That is such an important thing for you to look for. Pretty much most people are choosing to store their data off in the cloud because its storage is so affordable. It's very, very common for people to pick. Whether they're connecting to OneDrive, they're connecting to a Google Drive storage, or they're connecting to Dropbox, you're going to see that inside these Windows artifacts, inside those forensic sprinkles. So, another bonus to the Windows 10 system is some special things that people might not always notice that you have the capability to review and to look at. So when we look at our different artifacts associated with it, we have one particular artifact that can be super valuable to you. And some of you who might be more of the DFIR nerds, you probably don't use this function. You might, just because you're big Halo fans and so you love Cortana. But lots of the Windows community, so the public that is using Windows as their primary operating system for Windows 10, will use Cortana to be able to help them navigate through their system. So when they use Cortana to navigate, what they're thinking is that obviously the AI is just helping them get around, find their search results. I did a search results for Star Trek in here because I'm a huge Star Trek fan. Those things are going to come out in my Cortana artifacts. I'm also going to see the exact search results of the pages that she took me to, and then obviously display the information so I can get thumbnail details from those Cortana searches as well. The big thing is that Cortana, because she's an AI, she's also designed to kind of learn and add that enhancement to my Windows experience. And so you start seeing things like her speech recognition and her getting used to me as a user. And then on top of that speech recognition that you'll see in here, we have my recorded speech. I consider this one of the best forensic sprinkles that you can get with any type of device is when you actually have a recording of your suspect doing the searches. There's zero doubt that comes into mind when it says, oh, I'm looking up 7 ways to make a bomb, and you hear my voice saying that in the records that are recorded. So Cortana data and those artifacts can be a huge benefit to you in triage because it tells you how your suspect is using their system. And remember, when you install Windows 10, they're really a proponent of having you get Cortana set up as part of that process. And here, oh, and again, our media data with Cortana. All right, so we've talked about analyze with the computer side. We've talked about some of the lovely artifacts that you get that I call our forensic sprinkles. So let's talk about smartphones. So smartphones has kind of grown up in their storage capacity. They didn't used to be this large, but now it's pretty common for you to have a device that has a minimum of 1 terabyte of storage that you have to process through. The problem you have with a smartphone and processing through 1 terabyte of storage is that you're trying to suck up the ocean through a straw. It's really that much data that you're trying to put through a very, very tiny pipe. And so it's not realistic to do that within the triage environment. So you really have to kind of pick and choose. I have examples up on the screen here, some of the latest devices. So we have a Galaxy S10 that has a terabyte of storage. It has 12 gig of RAM, 6 cameras. It really is just a portable PC when you want to think of it. And we look at some of the Apple options where we have 1 terabyte available on our iPads as they're really trying to push over where it can become your primary system. We're going to see the storage capacity grow larger and larger. Your advantage you have is that with Android devices, you do have a media card option, as most Androids have that capability. With that, that gives you a different methodology that we're going to talk about for collection. So here's our mobile data triage. The information we have with mobile data triage is not quite as detailed as what we get with our Windows triage. And it's because each system is a little different, and a lot of times they're using a third-party app to be able to control some of this information. We still get some good solid basics, whether we get the device information, the list of installed apps. Again, I find that a very big primary area. Our contacts, who our ICE contact is, so our in case of emergency contact, potential locations and recent web searches. And just as a side note on the location information, remember that that data is not always all the locations on the device. And I say that because location data is actually a very difficult piece of information to be able to pull out of a smartphone because it really is just a string of numbers. There isn't a direct form that allows it to be pulled through a regular expression or anything like that. So do keep that in mind. That area, you're going to see more location data as you continue to do analytics through the device. So as we look at our device information, here's some of the properties. And I know you're thinking, why do I think the properties are really valuable in triage? The advantage to this is it's telling you kind of what is connected to this device. So does it have a media card? Does it have a SIM card still intact to it? Am I getting additional information if I'm law enforcement that I can then go to the provider and be able to provide that to get additional legal requirements for more information? The installed application list, I think this is kind of like an index to a book. It's telling you all the great chapters that you have to look forward to. So you have everything from Chrome to Facebook to Fitbit that you're going to find that type of information and be able to use that in your triage investigation. So here's our problem with smartphones though. Once we've done that initial triage, we really have to choose what our next step is going to be in the process. I mentioned earlier, it's about 90 minutes to be able to do a very average phone for a full image. So you're going to have to pick and choose. Do I want to pick specific areas of data like I had on my list earlier, or am I going to attempt to do a logical examination or a physical examination? That's when we have to simplify. So, how did your suspect use it? That's really the big question when it comes to a smartphone, to be able to work with that data. Since we don't have quite as many options with it for just picking and choosing specific headers and be able to get data from apps that way, we have to look how they used it. So what I did is I took an Android media card and I mounted it up in a media card reader, so a pretty standard micro media card reader. There are forensic ones available for many of the hardware providers out there. And by mounting up that media card reader, I haven't made my changes onto the evidence itself, but I still have a wealth of information I can see in my triage. The advantage is that I'm now reading directly from that media card reader to the media card. So I've cut down some of the commands that happen from the firmware OS to that, so I could make it faster. From here we can see I have a Rove, I have a Snapchat, I have USAA as an insurance, they have Facebook, Text Now, Yahoo. These are apps that are then storing their data off to the media card. So if I know I have a very limited window where I'm going to be able to work with my data, it's an okay instance to pull out the media card to be able to do that as a separate image at the same time, instead of just looking at it directly through the firmware. Typically your acquisitions are going to be, I'm going to take the device and I'm going to do a logical acquisition. That logical acquisition will include the contents of that media card. But when you remove it out, I'm able to see that data independently, and now I can image that media card as a traditional separate storage device. So here are my apps and my databases associated with it. So when you get a list of apps, we give them to you in two forms as far as the E3 platform goes. We show you what we can parse directly, but we also always show you the actual directory that the app data is associated with, because at the end of the day almost every app is a database, and because of that you just have to do individual analytics with each of those databases. Pick and choose when you want to look at those apps based on what they're using. If you see they have Chrome and they have Fitbit but you didn't get a Fitbit, then you know that's something that they're probably wearing and using frequently on them, like I do. So I always ask the basic questions, the who, what, when, where, why, all of those that you get from your original schooling that you did. So first thing I ask with a phone is who were they talking to? So I look to a lot of the messaging apps out there to see what is popular. It's actually a pretty small list when you think of the ones that are popular. Most people don't use the obscure ones. So I might have Facebook Messenger, I might have WhatsApp, they might be using SMS. Understand the context when you start going into that simplification of that analyst stage, that who they are talking to, is it one-on-one, is it group messaging? It should show you in those app properties. Both these ones I have up as examples for you are ones that are parsed and easily able to go through. Where were they at? That's the next big question. I brought up the location services information earlier, where it is hard for you to just search for a geolocation because it is typically just a string of numbers. That would make sense for a Latin long. However, in that lovely keychain data I mentioned earlier from Apple, you can get information like the map history. That can tell you, again, that geolocation information. I've just obfuscated it here in my screenshot, where they might have gone to by using that device. Look for those little teeny forensic sprinkles, the forensic nuggets, whatever you want to call them, because they exist in a variety of different areas. But this is another really good example on why I always do an encrypted backup as part of my forensic triage with an Apple. What were they doing? So I use myself as an example with that. I'm pretty religious about wearing my Fitbit. It's one of the first watches / fitness devices I've really liked. It's lightweight, it's great, it keeps tracks of things. It makes someone who has a desk job feel like they're exercising a lot. So you can tell in my Fitbit data I have up on the screen though, we see a behavior change. So we have, I'm at 17.9 miles running. That would be fantastic if I had that capability. I don't have the knees for doing that anymore. And then it goes up to 71.8. And I am not the road runner, so that is not happening. But that tells me that my person has now switched from maybe walking around to being in a vehicle. And it has all the time, date information, and it again has the coordinate information. So those geolocation details can tell you a lot about where your suspect was actually going. And I always like to take my geolocation data. A lot of times I'm going to export it out of whatever tool I'm deciding to use, and I'll export it out, take it as a CSV, and then convert it to a KML. Those are all importable into Google Earth. It makes sure I get always the latest maps, and they're free. And I can literally see the little path that my suspect might have been going. What else is there? So that's another W for we're going. Who were they talking to? Where were they? And what were they doing? So what else is in there? That's when we're talking about cloud. I have a great example up here of some cloud credentials for you because I think a lot of times you might forget about the cloud. It is critical. Pretty much everyone is connected to the cloud. If you have a smartphone, you're connected to the cloud. So you want to make sure that you're getting that consent information. So they sign extra paperwork if you're doing this on the private sector or on the public sector side. Get that consent side of it signed. And then when you recover the keys, go ahead and process the keys to a point that you at least know what accounts were associated with the device, and then choose if you're going to proceed farther based on your legal requirements. I have an example for you here of our cloud import wizard inside the E3 platform where I see Facebook and then I have the account login and password. If my suspect has given me that information, so Amber and my password to my Facebook account, while I'm still working on their other devices, I can type this information here, I can authenticate, and I can image their Facebook account down. Here's the nice bonus for you. The Facebook function for cloud is available in our E3 free version. So if you don't have that and you haven't started to learn E3 as part of your investigative process for digital data, it's one more reason to get that downloaded and set up. And we'll make sure that you have that link in the follow-up from the webinar so that you can get that downloaded. But why wouldn't you want free cloud acquisitions? It's always a bonus. So we have our final section, which is our timeline. So, timeline on a smartphone. It's a lot easier to put together a timeline on a computer because you have a lot of functions within the operating system that allow you to do that in the first place. When you're working with a smartphone, I always work with the device first and see what I can see just by doing an initial quick look. Most of the time you can pull up all the things that are running in active memory on the smartphone device. This tells me what they're using at that time. And Android, you can pull up just by hitting one button. It shows everything that's running. You can scroll through it. You haven't made any changes, but you're able to see what were they doing at the given time. Apple has something similar. It has a process list and it shows you all the active processes running on the device. So it's going to tell you whether or not they're using certain services on it. When we process it for forensics, we can do a special thing in E3 for Android that allows me to actually generate an activity timeline. It's one of my favorite features. I bring it up often in different webinars because it's one that I think a lot of people are not paying attention to. So what you do is you go through and you allow the service to run on the device, and then I can pull up exactly what was happening on the device. The big advantages for this type of timeline investigation is that my suspect couldn't make any changes to this. This is all something that happens in the system itself. So it's really indisputable evidence, which is excellent. That's what you really want in digital evidence. So you see in my example here, I can tell when they were doing messages. I can tell when they were accessing a cloud camera. They had a game running like 2 dots. They had a Fi connection, which means they were connected to an IoT device. Fi is, this is my phone that I processed for you, so this is my dog's collar. So it shows you what I'm working with in my environment. Then you have to determine, was it the machine or was it a human interaction? And I have my example here on the screen of Gmail, where it says move to foreground or move to background. That is telling you, was it a computer doing the action, so the phone, because again, they're a smartphone, they're doing a lot of changes, adjustments, app choices without you, or was it me actually interacting with the screen and choosing those details? Where we have move to background, that was not me as a physical person interacting with the device, where move to foreground was. This is an excellent way for you to deal with things such as traffic incidences, where you will have a question whether or not the person was on the phone when the incident occurred, different things like that, or whether or not, oh, I already have the screen, sorry, hang on. So traffic incidences, who were they talking to before a murder might have occurred, or even when there was a breach within an organization, what services might have been running on the device, was the vector for those breaches from the mobile environment. And the picture I have there of the car accident, that's from an accident that I was involved in, and I went through the guardrails and I was unconscious. I didn't know what happened, but my activity timeline let me show I was definitely not on my phone, I was not a distracted driver, it was nothing like that. It was more of a medical issue that had occurred that I had to make changes for and go through the court system and say this is what happened. It drives a forensic investigator nuts to not know what happened. And I immediately went to my smartphone, my Fitbit, and my Amazon Rove device to be able to start the investigation to say what was going on when that accident occurred. So the big question, does it disappear? Because sometimes when devices have active RAM functions, they do have their data disappear when you reboot the device. It loses power, all a variety of different things. The nice benefit on these particular devices is it does not go away. We've been able to pull up to, I think it was almost 3 months of data off of someone's device from their activity timeline. And to know down to the second every function that they were doing on their device is some really valuable information. And the best part, it's a very quick acquisition, which means it fits into our digital data triage of 20 to 30 minutes. So here's our timelines that we have to work at. So full imaging of machines, etc., is the longest process that you have. So best options, of course, are to pull drives and do it through that methodology. You can do it through software. I brought that up earlier. But know that doing a full logical image, a full bit stream image of a computer, it's just going to take too long. Stick to going focused areas. So I'm looking for documents, images, whatever it may be. That's what's really going to make your triage really beneficial. And the second side of it is remember that you want to be able to triage data without having to process through 100% of the file system. You can do that in minutes, and it starts building up that treasure map to where your potential evidence might be. Next timeline that you have to watch out for is when you have to do bypasses on locked devices. No, most of the time you're going to end up doing a chip bypass where you're actually doing a chip imaging, not a chip off, a chip imaging, and they can take a while. So that's going to break into that much longer than a triage capability time frame when dealing with smartphones. So our goals are always to customize our acquisitions and then make sure we're doing the same with our mobile and customizing it there to hit that 20-minute time frame. So to review, we want to have it fast. We want to find, we want to analyze, we want to simplify, and then we want to create that good timeline that comes out of it. Because our goal of triage isn't necessarily to finish our entire examination as it is to make sure we know what our next logical path is going to be. So because we're doing a recording of this for everyone, we always cut out all the questions. But if you do have any questions, you can reach me at email at amber@parabon.com. You can follow Parabon Corporation as Parabon Corp on Twitter, or we also have a LinkedIn and a Facebook page. And we also have a ton of YouTube videos up at Parabon Forensics, all one word, which is our YouTube channel. My personal Twitter, which I also put out a bunch of DFIR and investigative factoids, is Ginger Wonder Mom. So please reach out to us. We're happy to share more information with future webinars with you. Make sure you opt into our mailing list and we'll hit you up when we have new ones. We have additional webinars on Facebook, on smartphone investigations for Android, and a separate one for iOS, and then some new fun ones about very specific data such as Discord. So we hope to see you at a future webinar. Thank you for joining me.